For the last couple of years, I've seen a renewed interest in magnet motors, so I thought I'd bring out the one that I built 13 years ago and maybe show some points that might help others that are engaging in this. Over the years, I've seen maybe hundreds of different designs on YouTube, and really none of them work. It's kind of sad because they all share these similar flaws, and one of the biggest flaws that they share is trying to close loop the magnetic stator. And you just can't do that, because if you do that, the rotor and stator relationship will reach this point of equilibrium where it just slows down and stops. Even the ones that have the multiple discs that are offset a little bit from each other and multiple stators to go along with that, same thing. They just don't work. They may work for a few seconds, maybe even a minute if you're lucky, and then that same equilibrium will kick in with the magnetic field, and no one really can explain why. They just see that it exists and it happens. But it reaches that equilibrium and everything just starts slowing down, then comes to a stop. So you have to keep an open system here, and that's why my third magnet is an electromagnet. So I have the neodymium stator, and then I have the one rotor magnet right here. It's very powerful. It's N52, and you can see that it's got a pretty great distance from the stator to the rotor, but you can also see that the distance from the electromagnet to the rotor is quite a bit closer. I'll just bring it up so you can see. You see, it's real close, and the reason for that is that the electromagnet has about 1/8 of an inch thick case that's steel, and that magnet is really attracted to the steel, and then the core of the electromagnet is the exact same diameter as the magnet itself, and so this magnet is extremely attracted to first the case and then the core. And so what you want is you want this to leave the exit point, which is the end point is right here, and the beginning point is here. So at the beginning point, you always have this really strong repulsion. This particular magnet works in attraction on this spiral. It is a spiral. It's not like the spirals I've seen over the years, like the Fibonacci spiral is very popular. It's the golden mean. Mathematically, it's a beautiful thing, and you find it in nature, but it's a small loop that starts tight and then it ends up going in outer space at the end. That just doesn't work for a system like this. It may be beautiful and it may work for other things, but for this it doesn't work. And then you've got you know, aside from the closed loop one, I've already said that doesn't work. You've seen that. And then you get the V-gate. Don't even bother with that. It's just silly. You're not ever going to, even if you got it to work, there's no torque. You got to have torque. So there's three criteria that you have to meet to make a really successful magnet motor. That's 1, acceleration, 2, torque, and 3 is inertia. Now you can get the inertia part by adding some flywheel weight to either your rotor or like I have on the back side, which I'll show you in a moment. And what that does is it helps it, when it's coming through, that extra weight will help it carry through this point right here. Now with this particular machine, you know, I started it 13 years ago. It took me an entire year to get this magnetic spiral and interaction with the rotor to perfection. And I mean, I really did reach the perfection. I think I got it as far as you could possibly take it, but it also includes the interaction with this steel enclosed electromagnet and the type of core that it has and all that. So everything is super critical. But what you see here is the exact same configuration from 13 years ago. Or 12 after I had perfected it. The distance between the magnets is critical. The distance between the magnet and the rotor magnet is critical. Everything is critical, super critical. But once you have it down, there's no reason to change it. Like the old saying, if it ain't broke, don't fix it. So I haven't changed that. Now I have changed the appearance of this cosmetically. I've made it so that you can see through, and I've got a clear rotor. The early one had a solid rotor, so I've changed things like that. But the reed switch that I've got here that controls the pulsing for this, because it's only a fraction of a second that this pulses, that reed switch is the exact same one, 13 years. The solid state relay that I have down here for the field effect transistors, 13 years. Same thing. Nothing's wore. The same electromagnet. Everything's identically the same except for those little additions. This isn't a part of it. This is just a 12 volt LED, and I've got that on for demonstration purposes to show you one thing that I'll mention in just a second here, because the other thing is this up here. That's just a calculator. I've made so many calculations on this thing over the years that, you know, I got tired of fumbling around and going from bench to bench trying to find where I set my calculator. So I just took a credit card size one and mounted it to it. Now I can just punch the buttons and bam, it's done. So anyway, that was just me. But okay, so to get back to the acceleration point, when I don't have the weight, I've got a flywheel on the back of this and some other stuff I'm going to show you. But when there's no weight, if that wasn't there, from this point right here to where you get past the repulsion and let it go like this, it used to be, without the weight on the back, it was a fraction of a second. Super, super fast. So I knew I had a good acceleration thing going. And what's the other thing? So it's going slow right now because of that flywheel weight, but I've also got a really beautiful three-phase alternator that's also attached to that. So right now, the whole mass weight that this one magnet is responsible to power is about 25 pounds. And it's not just 25 pounds of balanced weight. It is balanced, of course, but there's a three-phase alternator and you can put that sucker under load. I mean, don't call this much of a load because it's running off the three-phase. It's 12 volts, but I mean, I could run 20 of these or maybe more from that three-phase alternator. What I've got on it right now is just a little battery pack down here. It's just, it's nothing but four, it's Velcroed on, and it's nothing but four, if you can see that, 4 grocery store variety alkaline batteries, AA's. So you're only going to get about 6 volts out of this thing. And so I wanted to show you that this 6 volt source, it's got a little switch on it. I've got it turned off right now. Make sure it is, yeah. And so I wanted to show you that this 6 volts will turn this thing and yet power this 12 volt LED. Now, okay, that's not much of a load. It can power other things, but I'm just showing you this as an example. All I'm doing is trying to help others to make a better design if they're going to build a magnetic motor. I'm not trying to prove anything. I'm not trying to say that this thing will take you to the moon and back, but I'm just pointing out some good things to avoid, you know, pitfalls and flaws. So like I said before, don't try to do a closed loop system. Keep it open and bring in some other influential sources like an electromagnet. It's still a magnet, but when it hits the electromagnet, this is a repulsive force, whereas it's an attraction going all the way around with the rotor versus the stator. But what happens is that I've got this magnetic stator set up so that the maximum amount of acceleration is the last 45 degrees. Now, the reason for that is to help it get through this right here, this zone right here, because the repulsion factor is really strong and it doesn't really want to leave the end point. So you've got to make that transition, and you've got to have all the help that you can get. And the other thing that helps you get through is the flywheel weight that I've got on the back. So, you know, with those two things, those are like outside forces other than the magnetic fields themselves. These are really, really important things. So you've got to pay attention to that and follow those rules, and you'll have a good, successful machine. I'm going to show you how this thing works. It's awesome. Let's start right now, and let me just show you that 45-degree acceleration. Just watch the LED here. I'll just bring it up here. Oh, what this does is when it's attracted, when this magnet comes around, notice the angle of the magnet too. The angle of the magnet itself, you know, perpendicular to, it's not perpendicular, it's on an angle. So it's about, I think it's about 20 degrees, something like that. So it's very critical. But when you use this in repulsion, that magnet only wants to go in that direction, and that's the direction of rotation. So with 96% of rotation already, without even pulsing this thing, you got that little 4%. all you have to do is get it past that little 4%. So this thing just barely even bumps it. Like I said, if you're running this thing at 200 or 500 RPM, it's going to bump this sucker, you know, maybe if it's 500 RPM, was about 8 times per second. Well, that's pretty fast. So you also get the back EMF off this when the field collapses inside the electromagnet. And so I've got a couple of connections right down here that you just connect to, and you can recharge other batteries and utilize that. Otherwise, you're just throwing it away. So it's actually, if you want to consider that free, it's kind of considered free, though you paid for something to get the energy into it in the first place, but it's something that you would normally throw away. So I look at it as, okay, it is a little gimme there. It's a little freebie thing. So we'll just go ahead and charge some batteries, and it does that really great too, by the way. But check this out. Okay, I'm just gonna give it a little flip, and then watch this at the last. Or maybe I pushed it too hard. Boom! You see how bright it gets? Right there. Here it comes. Right there. That brightness. And look at the rotation again. Now it's going to bounce between the poles. If you can get your machine to bounce between the poles, you know that you've really got something that you can work with. It's an indication that you're really going to have some torque out of this thing, and this thing has massive torque. All right, let me just show you here. First of all, spin this around and show you. Let's see if I can put it into, yeah, I guess you can see that. All right, here's the flywheel. So it's going to turn in this rotation like this. You can see the three-phase. There's the coils are mounted in the center of this polycarbonate plate here. And then the rotors, there's double layers of N52 on both sides, covering the coils like this and spinning around. So it really does do a good job, and it generates more power than you think for as small as it is. And it's about, I don't know, 8 inches in diameter, something like that. So, you know, you've got some mass weight that you have to turn, and then the load. Now these two little alligator clips here just go to that LED out there, and like I said, I could, you know, with this three-phase, I could probably power 20 of those things or more. But there's the 3 phases coming in, and these light blue connections into the bridge rectifiers to rectify it into DC, and then you just you know, clip on to the positive and the negative of the bridge rectifier and output that power. Now you can output that power for whatever reason that you want. So let's just turn this thing on and give it a start. Now you can see that it's actually speeding up. It will accelerate. Remember, it's only a 6-volt source down here, and this electromagnet is a 24-volt electromagnet. The lowest it can take to handle this job is 6 volts, and that's why I wanted to show it with a tiny 6-volt pack. I don't use this on here normally. Normally I use something like 16 volts, which is really nice, or 24, or in some cases 40-volt lithium. So, and 40 volts will really run it, and you'll really get some nice output off of the collapsing field of this for your little spikes. Or actually, they're pretty big spikes. They charge up batteries pretty fast. And when you're running that fast, the 3-phase really jams out some power. I've got it set up to switch between delta and star, and so you can get the voltage up to, you know, 50, 60 volts or down to maybe 24, something like that. Okay, you can see that it's going very, very slow, but it is accelerating, and it will more and more as it goes. This is just the slowest speed I can possibly get it to run. But I wanted to show you that the 6 volts can generate this, you know, like I said, that's a 12-volt LED, and it'll light up as low as, I think, about 8 volts, and where it'll start to light up, and then it gets, you know, the brightest at the 12-volt point, which you can see it. And you can still see it intensify in that last 45 degrees, even the way it's running right now. There's no capacitor on it to smooth that out, to hold a little bit of power in between the phases that it's showing you right now. These are the 3 phases, and you know, it's a 1 2 3 1 2 3 1 2 3, and so, you know, that's why it's pulsating like that. Obviously, capacitors just smooth that out right away. So the idea that I'm looking at for this is, you know, to have a source that you can port that 3-phase power back into obviously you can't recharge alkaline batteries. I've only got those on there for demonstration to show you, and this here as well to show you. But typically I use this, and I've used this thing, oh my gosh, over those years. I don't know how many videos I have of this on my YouTube channel still. I still have a bunch of them. It's old, it's white. I've had everything and its brother attached to this thing before in the past. Maybe I've got, I don't know, 4 or 5 videos, something like that on this machine. And it was a test bed for all these different experiments, and they were all really great experiments. You can look at them. But I like the configuration that it is now. I like the looks of it. I like the flywheel that I've added to it. I like the 3-phase that I've got on it. Everything balances out and works really, really great. So what you do is you take the power that's coming off that 3-phase, not this. If I turned this thing faster than this, it would burn this thing, go into a nuclear meltdown. but so I don't use it. But anyway, so you take that power from the 3-phase and port it into something that you're going to charge up front here, and even add this, the collapsing field. These spikes can add in with the 3-phase as long as it doesn't go back to your source energy. Now the 3-phase can go back to the source, that's not a problem. So the obvious thing to use is what? Capacitors. Because batteries charge so freaking slow. Think about it. This thing, once that magnet right there, you know, it's pulsing, and even though it's going really, really slow right now, I don't know what the RPM is, but it's extremely slow. But while it's just pulsing, it's just drawing 1/fraction of a second of pulse, especially at higher RPM with the electromagnet. But on the other hand, the 3-phase alternator is working all the way around constantly. So you're just taking a little bit of power just to bump that over, because where it stops and lines up with that electromagnet, that's in the neutral zone. Like I was showing you, it can fall forward or it can fall backwards. It's right in the center. And that little tiny push that it gets from this electromagnet, with that magnet angled the way that it is, to give it to make it go only forward motion, just a tiny little bump, boom, and you've beat that 4%, and around you go, and the acceleration cranks. You should see this under some serious power. I'll probably show it to you. But anyway, so the idea is to have a source that you can recharge while this is running, and have a secondary one that you can use this to, because you cannot return this to your source power, whatever it may be. That just doesn't work. You can take the 3-phase and put it with this, or you can take the 3-phase and put it with your source, or you can take the 3-phase and do something else with it. Whatever you want to do. It's a load. You want a load. Remember, you've got to have acceleration, torque, and inertia. This gives you all 3 of those. So there's a lot that this machine can do. And okay, so where do we want to go from there? All right, so we're talking about, I try to make this short. There's so many more things I could tell you, but I'd go into so much detail you'd be bored to tears. So anyway, so what I'm thinking is something like this. I put blue painter's tape on this supercapacitor just to mask the identity of the manufacturer, because we're demonstrating the magnet motor. But anyway, to charge something. Again, I don't want to use lead acid. I don't want to use nickel metal hydride. That's old school technology, and I don't want to use lithium, even though they're making good strides with lithium. What you're missing, though, is the advancements that are being made with graphene. What the crap, man? Why are these companies sticking with lithium and trying to perfect that? I know it's the energy density. It's got a ton of energy density in it. But with graphene products, they're going to match that energy density, and you're not going to have toxic heavy metals in the dump and a battery that'll only charge several thousand times and it's done with a short life. But anyway, these supercaps are nice. This is awfully big. I mean, you can see it's 2.7 volts at 3,000 farads. But what I wanted to show you, I've got over here, what I wanted to show you is what I'm talking about. This as good as this is, and as popular as these are, and as much as of energies that it's hold, 3,000 farads is a lot of capacitance for a capacitor. But this thing's heavy. It's you know, it's a pound and I don't know, 1.2 pounds, or I don't know, something like that. It's very heavy, and it's bulky, and it's big. Well, here I've got this new one here, which is pretty small actually. You can see that. I think you can see that relative in the camera. Yeah, you can see that. Okay. Anyway, this is a graphene supercap. This is 2.7 volts at 3,000 farads. This one is 2.7 volts at 3,000 farads. It's the same energy density as this. This is now like obsolete. This is the bad boy of the future. Why in the world? Look at the tiny form factor of this, people. This is freaking awesome. If you use this form factor here of this cylinder, you could put, I don't know if you can see this, and I get it in the camera. You can put 6 of these around inside this thing. If it was empty, you could put 6 of these around and one right in the center and have 7. And look at this. It's exactly half. It's exactly half of this in height. So you could put another 7 of these down here. You'd have 14. You'd have 14 of these bad boys inside this one cylinder. So if you put them all in parallel, you'd still have 2.7 volts, but instead of 3,000 farads, you're going to have 42,000 farads. Holy crap. Yeah, I mean, think about it. All right, if you put these things, I can't show you on the table. Maybe I can over here. It's not okay. So if you set these down and you put them like that together, as small as it is, it's less width than a cell phone, and it's less height than a cell phone. Obviously, it's thicker. You can see, and you know what size this is, so it's not hard to tell by the relationship to the dimension of my hand. What size it is. I'm just not going into detail on this right now, but anyway, so the idea is to use this kind of technology. And guess what? The best part of this is these suckers, even having as much as this has as far as capacity, these little things will charge in as little as 5 minutes time. 5 minutes time, and you've got 2.7 volts at 3,000 farads. 5 minutes to 10 minutes actually is, you know, depending on how much current you put in there. So if you can get this in a 6-pack, all right, and it'll give you 16 volts at 500 farads when they're hooked in series for the 16 volts. This thing runs like a scalded dog on 16 volts, so it's a really awesome voltage, and I'm probably going to keep it at that. But can you imagine 6 of these as opposed to 6 of these? 6 of these, like gosh, it's going to weigh about what, 7 pounds, 8 pounds, something like that. 6 of these, this thing is as light as a feather. I mean, this is really awesome. Graphene. Remember, you've seen videos about graphene, and it's always the wave of the future. Well, crap, the future's here right now. Why can't we take advantage of it now? What are you going to wait for 2050? I mean, come on. So I'm going to use it for this. So think about this. If you had 6 of these together, the cost of that, you can buy it. That's available. You can get it on the internet. You can go to Amazon and get it. 6 of these is going to cost you anywhere from about $260 or $280, something like that, up to $500. For 6 of these with the little balancing circuits on it and all connected together and, you know, ready to go. Well, you know, that's quite of a range of profit that somebody's making somewhere along the line, but still, you know, on the low side. But there again, you're going to get 500 farads. What if you took 6 of these and you got that same power, and you put them in series, so you have 16 volts, and you have the 500 farads with 6 of these, and then you took 6 more of these and did the same thing, and then 6 more and 6 more, so you had 24 of these. So it'd be like 4 groups of 6. Now all of a sudden you're going to have 16 volts at 2,000 farads. Oh my gosh, can you imagine the size of this at 16 volts at 2000 farads? It would probably weigh, what, 30, 40 pounds? And it'd be the size of a couple of concrete blocks or something. It'd be massive and it'd be heavy. You can't use this for EVs. They're too heavy, they're too bulky, it's crazy. But these, you're going to be able to use these for EVs. So you need something that's ready to go, that this can be used for so many different things. It's just absolutely amazing. So, so then what I wanted to show you is, I've already done it. And here it is. You see? Pretty nice. 16 volts, 2000 farads. This will give you, as small as this little thing is, and oh, check this out. Oh, these wires. These wires are 8-gauge wire, and it's silicone jacketed, so they're super flexible. And just press this button, 16.2 volts. Yep, shows you the state of charge anytime you want to see it. And 72 watt hours. 72 watt hours in this. It's got 24 of these inside, and it's about, this is like 6 by 6, 6 inches by 6 inches, and it's about 1 3/4 inches tall or less. So very small, very lightweight. Not like the concrete blocks one you'd have in the other. And so, can you imagine? I mean, think about if you had these. I'm going to slide this back so this gets a little feature. And in fact, let's just put a little zoom on this. Get down there. Okay, so you can see it a little bit better now. And also, this comes with, it's ready to go. Can you see that in the camera all right? I think you can. Yeah. So it's ready to connect. Red one's the same. Has a little flexible cover that protects it, because the last thing in the world you want to do is short these out together. I mean, what, you'd probably, I don't know how many amps you'd get out of that, 10,000, 20,000 amps, something super, super high. You can look at the specs on anybody else's super cap out there that's big, that has any kind of power. But here it is. This is it. So if you take this and you're running this, let's put it back up in, and you're running, this is running this, and then you can take another one and it can be charging. It doesn't matter. You can put these two together if you want. Just stack them. Yep. Or 3 or 4. Or whatever you want to do. How much power do you want to put in? How much power do you want to get out? I mean, so 32 volts, put them in series. Put these suckers in series and run the thing on 32. It'll pulse this. It's only meant for 24, but when you're pulsing at one time, a fraction of a second, even if it's doing that 5 or 10 times a second, this thing barely even gets warm at that. It's only designed for 24 volts, but put 40 volts in it, or yeah, I haven't gone over 40 volts, but okay, I got to show you one more thing. So you go to my website at quantummagneticstore.com, and you'll see the product page for this. You'll see all kinds of applications that you can use these for. You'll see what the cost is. You'll see all the specs and the warranty, and everything that you get off of these things is there. But I wanted to show you as a point of relativity. Okay, this is a 40 volt lithium. See that? Okay, 40 volt lithium. On the back, it says, read that right there, 72 watt hours. Okay, 72 watt hours. Lithium battery. Takes quite a while to charge this thing up. This one's charged all the way, but it takes a while. This takes 5 minutes, 10 minutes to charge up, and guess what? It's 72 watt hours, the same as this. Look at the size difference. There's not much size difference, people. You get it? Graphene is the future, and the future's right now. When are people going to wake up? Oh, lithium. Oh, we got to have lithium. Oh, yeah, it'll burn and it'll explode, but oh, we got to have it. It's toxic. Oh, we still got to have. This ain't going to burn and explode. These are capacitors. For crying out loud, they're lightweight, they're small. You could use this for EVs. You could even do something like this. Check this out. This is kind of cool. This is just an idea. It's a stupid idea. You'll see all kinds of ideas on the website. You got to go there and read all that stuff. But if you took this thing here, this is just a little AC inverter that plugs into the power port of your vehicle or your cigarette lighter or whatever you have. You can see the fitting on it, and it also gives you a 5-volt USB output. But otherwise, you get 120 volts, 60 cycles, and it can handle 100 watts. But you got 72 watt hours in this thing, so you can get some power. So what the heck? You put a piece of Velcro on the back of this and a piece of Velcro on one of these, stick that sucker down, get a little reset at the auto parts store and wire it up and just connect it to these and just stick that sucker in there, and it's a little tiny unit, and you got portable AC power just like that. Portable AC power. You want more? Then stack 2 of these together, or 3 or 4. It's still going to be lightweight, and you're going to have more. Now you'll want a bigger inverter when you do that. But still, I'm just telling you, the applications of this are just freaking endless. So think about it. Go check it out at our website. If you're, when this video hits, I know that we're gonna get a lot of response off that, and this would make a super, super gift, especially this time of the year. But a gift to you, or a gift to anybody else that that could use this. Oh, imagine, here's another one. I got to tell you these are just incredible. I get excited. If you look at as small as this little thing is, if you put this next to the battery or hooked it onto a battery in your vehicle, you are never going to be without power if that battery dies. I mean, the winter is on in the north and other areas. It's like winter all year round. But I'm just saying that if you have a battery that's kind of weak and it gets super, super cold and that battery dies and you can't even crank your car, this is never going to have that problem. This is good for I think it's 40 degrees below zero, minus 40. Yeah, I think it's like minus 40 or minus 50, something like that, for these super caps, for these graphene super caps. Remember, graphene, there's a big difference in graphene and standard super caps and other capacitors. So, all right, so just remember that never not be able to start your car, portable AC. I've got dozens of, well, maybe not dozens, but there's a lot of application ideas on the product page for this on our website. So check it out and make a decision if you want. You can buy multiple of these. You can buy one. I don't care. Whatever you want. And but you might want to do it pretty quick, because I know at this time of the year these are going to go really fast, and we're going to have probably end up with a little bit of a waiting list. But we're going to try to get as many together as fast as we can and keep the source going. That's it. Okay, the video's long, so I'll spare you the running this and charging, even though it's really freaking cool. But I think you get the idea. I mean, this is new. This is good. This is something you're not going to get anyplace else. So come see us.